Hi, everybody. Thanks for joining us this evening. Tonight, we are starting our programming for NASA at My Library with Michelle Nichols from the Adler Planetarium, and we're doing Skywatching using your eyes. Oh, I lost my page. Okay, so Michelle is the Director of Public Observing at the Adler Planetarium in Chicago, Illinois, and has worked at the Adler since June 1995. She holds a Bachelor of Science degree in Physics and Astronomy from the University of Illinois at Urbana-Champaign and a Master of Education degree in Curriculum and Instruction from National Louis University. Ms. Nichols leads all of the Adler Planetarium's telescope, observatory, and public sky observing initiatives and events. So thank you for joining us tonight, and I will let you go ahead and get started.
All right. Hi, everybody. So if you are accessing this recording sometime during the month of December 2021, this is right up your alley. I'm going to go over a bunch of stuff that will be visible in the sky over the next few days and weeks, but also looking ahead farther than that, and let you know about how you can observe eclipses, meteor showers, the International Space Station, the Northern Lights, various things that you don't need special equipment to be able to see, or you don't need a ton of it. I am going to go over a bunch of tools that you probably have, such as a smartphone or on your computer, some websites that you might want to access in order to get some more information to help your sky observing at home, because we all share the same sky. And so it's fun to get out, but if you aren't quite sure where to start, just using your eyes and a few simple tools or websites will get you on your way. Sky observing is something that is completely free for everyone to do, so I hope you take advantage of it at some point. So why don't we get started? I'm going to share my screen, so give me just a second. All right. Okay, so you want to go outside. That's great. Where do you go? I get asked that question a lot. Where should I go? I want to see a dark sky. Well, what I've got up on the screen right now is a map of light pollution. Now, light pollution is light that goes where it's not needed or where it isn't wanted. Basically stray light that isn't doing something useful here on the ground. And so when light shines up into the sky, it reflects off of water vapor and dust and other stuff that's up in the air, and it makes the sky glow. And this light pollution problem is really bad. If you take a look at this map of the United States, you can basically pick out the entire eastern half of the United States by just seeing the lights that are escaping upward into the sky and lighting up the undersides of airplanes and birds. Now, anywhere on this map that appears bright white, that is some of the worst light pollution. Any place that appears black on this map is essentially a completely dark sky. Now, there are very few places in this country where you can experience a completely dark sky. Now, if we zoom in on the Chicago area, so I know Kenosha is up a little bit farther north than this, but I wanted to make sure everybody understands that where it isn't dark doesn't end at city boundaries. So let's use the Chicago area as an example. We've got Lake Michigan, and Chicago is a portion of the Chicagoland area, which includes dozens and dozens of suburbs. Now, if you take a look at the light shining upward, you would expect maybe if there's no lights out in the lake itself, shouldn't it be completely dark in the lake? Well, unfortunately, no. The light not only goes upward, it goes outward. And so we have this bubble, this dome of light over us. And the Milwaukee area, Kenosha area, that I know you've got light pollution up there as well. And you have to get kind of far from an urban or suburban location to start to get into areas that aren't quite as light polluted. Any place where the color is green or blue on this map, or even yellow, will be a bit darker of a sky. Now, as for where to go, if anyone is looking in the Western Illinois area, the Green River State Wildlife Area is a great place to go. And I'll betcha there are equivalent places, lots of them, in Wisconsin. So check your state park website, and not just the big parks. Check the small parks if you've got wildlife reserves and that sort of thing. Check those areas and see if you're allowed to be there at night. Just to give you an example of what this area looks like, I just showed you what the Chicago area looks like, heavily light polluted. With the pin on this map shows what the Green River sky is like, and it shows up blue on this map, which means it's one of the darker locations in the state of Illinois. Now, if I were to give recommendations in the Wisconsin area, believe it or not, the Lake Geneva area is not terrible when it comes to a dark sky. It's not completely dark, but you can at least start to see the Milky Way there. There isn't an overabundance of lights shining upward in that area. So if you're looking for a place that has facilities around, that is a place you can consider to go. If you want to go, say, to the Bong State Recreation Area, or up in Door County, Washington Island, Rock Island, those sorts of parks, those are great places to go. Here in Illinois, we've got an actual dark sky park as recognized by the International Dark Sky Association. You will start to see more dark sky parks and dark sky locations in the rest of the world as well, but we've got our first one. So that is the Middle Fork River Forest Preserve, just outside of Champaign. Now, it's not that this area is completely dark. It's not the absolute darkest location in the state, but it's at least a forest preserve where they have committed to preserving the dark skies that they have there as much as they possibly can, proper lighting in the park and that sort of thing. So wherever you travel, if it's within your own state, look at the light pollution map and see where it might be good to go to enjoy a dark sky. Now, make sure also that you do it safely, and wherever you go, make sure you can be there overnight. One problem in a lot of city parks, if your parks work the same as a lot of the parks we have in this area, one of the problems is you can't be in a lot of the parks after sunset. And so while a park setting might be good, you may have to look into the state parks and other locations like that to be able to actually be allowed to be in a park setting at night. Anyway, light pollution is definitely something we all have to contend with. Okay, so you're going to observe from Kenosha. Well, some of the things that I'm going to show you are definitely visible no matter what the light pollution is. There are a few things that I'll mention at the end that could benefit from going under a dark sky. So we'll get to that in a little bit. Anyway, wherever you go, if you go to a dark place, if you go to even a reasonably dark place, use red or orange light. Your eyes are most sensitive to blue and green light. And you may have noticed on a lot of our phones these days, at night, you can, or at least at night, if you want to use the nighttime setting on your phone, it tones down the blue colors a bit on your phone screen. And so that's to kind of keep your eyes from getting overly stimulated, your brain overly stimulated by the blue and the green light on your phone screen, just to get everyone to kind of chill out before you have to go to bed. But you've got a problem when you're out under a dark sky. If you turn your phone on, well, you've just ruined your dark adaptation, because it'll take 20 to 30 minutes of being under a dark sky to be able to actually get the maximum amount of light into your eyes that you're going to be able to see. So faint stars and other things that are up in the sky. So your eyes are least sensitive to red light. So if you go out and you say, take a book with you, or if you've got a flashlight or something, cover it with red cellophane. You can look for red saran wrap, red plastic wrap, or red cellophane, or red plastic that you can put over your flashlight. If you can do that over your phone flashlight, that's great. If you have apps on your phone that allow you to do a night setting, and I'll show you what that looks like on a website that I'll show you in a bit, to turn your screen red. That also helps as well. You can use orange light, but also make sure the brightness is toned down, because even red light at a really bright setting can mess with your night vision also. Now, in city locations and suburban locations, it doesn't get completely dark, so it's not quite as critical, but it does help. Every little bit helps. So red or orange flashlight, tone the brightness down. Don't or try to use your phone on the night setting to try to tone down those green and blue colors just a bit. And that will overall help your eyes see even more. All right. So when to go observe? You might want to consider the phase of the moon. Now, when would you want to go out when you see the darkest sky, when you don't have a natural source of light pollution in the sky, and that would be the moon? I'm being a little bit facetious, but the moon can be something you might want to go out and see. But if you want the absolute darkest sky, you want to go around the time of new moon. So there's nothing on this screen. Don't worry, you're not missing anything. New moon means no moon. New moon means you can't see the moon. New moon is the moon is in the same direction of the sky as the sun. And so the phase of new moon, right around the date of new moon, maybe a few days to either side, 3-4 days to either side of new moon, is a great time to go out, because that means the moon is not up very much at all at night. It's mostly up during the day, which means you're not really going to notice it all that much. So when it's only out at night for an hour or two and then it sets, because it's been up for a good portion of the daytime hours, well, that might be ideal for you. Now, if you want to go out for actually looking at the moon, you'll want to aim for maybe 2-3 days after new moon, and then up to just before full moon. And the reason for that is, if you do happen to take a small telescope or pair of binoculars with you, that's when you can point your telescope or a pair of binoculars at the moon, and you can see a lot of craters along this shadow line. So what's happening is the sun is shining on the moon. Half of the moon is always lit by the sun. How much of that half is lit, that is lit by the sun that we see on Earth? That is a moon phase. When the moon is in the same direction of the sky as the sun, that is new moon. When the moon is opposite the sun in the sky, sun goes down, moon comes up, that is full moon. And anywhere in between those time periods, so from new moon to full moon to new moon, that's when you can see part of the moon lit up by the sun. So when you have the date of full moon, so that may not be a date you want to go out, because that's when the moon is maximally lit by the sun, and it's going to basically wash out a lot of the dimmer stuff in the sky. So you always have to maybe glance at the moon phase and see what it is. If it's really close to full moon, like within a day or so of full moon, you may want to pick a different day if you're wanting to go out under a dark sky and see stuff. If you want to pick some days right around new moon, that's a good time to go. Just check your calendar. These moon phase dates are everywhere. So they're on weather apps, they're on calendars, they're all over the place. So as long as you're aware of the phase of the moon and it's not full moon or right around it, should at least get some decent sky viewing out of most of those dates. All right, let's check out tonight's sky. So I've got a web address up on the screen, and I'll give a slide at the end. So if you're taking a screenshot right now or writing this down, that's great. I'll also have this on a slide at the end. But I'm going to take you to this web address. So give me just a second. I need to switch the sharing on my screen. Okay, so this is a free website called Stellarium, and they do have a desktop and laptop downloadable version, free downloadable version of Stellarium, but this is a web-based version. So as long as you have internet access, say on your phone, you can access this site. So when it first comes up, you'll see the view on the screen. It'll change to an early evening view. I'll show you how to tell the time and the date in just a second. It will first figure out where you are approximately by where your IP address is. So where it detects your computer, where your router is or anything like that, it should give somewhere near Kenosha approximately. So when it first comes up, you'll want to get rid of this sidebar here on the left-hand side of the screen. So go up to the little hamburger symbol. That's what that little 3-line symbol is called. It's called a hamburger, and you want to click it. All right. If for some reason it isn't detecting your site, or you want to see what the sky will look like from a different location other than where you are, over here in the lower left-hand corner, it says Aurora, because that's where I am in Aurora, Illinois. If I click that, it's going to bring up a map and show approximately where I am. I can tell it to use this location, or I can search for a different location. So let me search for Kenosha, and I'll give it a second, and it will give probably the town and then also some specific addresses. So, okay, we've got Kenosha. Let's use this location. And you'll notice the sky looks basically no different from Kenosha as it does from Aurora. So the small difference in between our latitudes really won't make much of a difference in what we see. Now, over here in the lower right-hand portion of the screen, I click that. It's going to bring up the year, the month, the day. More than likely, when you first bring up this site, it's going to give a time, and then the clock will be counting. If you want to stop the clock, you can click the little button here to pause and unpause the time. And so I usually pause it just to stop it. And I have it set for approximately now. Actually, when I'm doing this program, it is 6:19 p.m. currently, so I have set it for 6:19 p.m. tonight. And you can see on the graph, it's showing you the hours of daylight and darkness. So that's what this is showing at this point. So I'm going to unclick that. So you can set this for dates in the future, dates in the past. If you want to see what the sky looked like on your actual birthday, you can bring that up. Or see what the sky will look like on a future birthday, you can bring that up as well. We can see a few other things here on the screen. I mentioned the night mode for this site. If you happen to get a Wi-Fi signal outside and you want to take a laptop outside, for example, and use this site, again, don't ruin your night vision. Go to the little eyeball. You can turn this completely red. And so that's the night mode for this site, and you can use all the features and it won't mess up your night vision. I'm going to turn that off just for us for tonight. You can turn on constellation information. You can turn on artwork if you are so inclined. The downloadable version of the software has a lot more features to it, but these are some of the basic ones. You can bring up grids on the sky. You can also make it full screen if you want, but I'm going to leave it the way it is for now. So what's in the sky right now? If I go out tonight or over the next several days to be able to see what's up in the sky, I'm going to zoom in a little bit. That enormously, really bright thing that's been in the southwest sky after sunset the past few months or so, that is the planet Venus. And upward from Venus, so basically if you face southwest, up and to the left, about 15 degrees away is the planet Saturn, and about 15 degrees away from that is the planet Jupiter. Now, what you see on the screen is different sized circles. That does not indicate size in the sky. That's indicating brightness. The bigger the circle on the screen, the brighter the object is in the sky. So Venus will be the brightest object aside from the moon when it's out. It's not always out at night, but Venus will be the brightest object. Jupiter be a little dimmer, Saturn will be a little dimmer. But if you take a look, there are no other stars really in the general vicinity of any of these that are a lot brighter or even remotely nearly as bright as Jupiter or Venus is. So if you're wondering if you're looking at Jupiter or Venus, Saturn, you are, because there isn't much there to compete with them. But that brings up a great question. How do you know when you're looking at a planet versus looking at a star? And a good rule of thumb, it's not always the case, but close enough. A good rule of thumb is stars twinkle, planets don't. And the reason for that is the beam of light coming through our air from a star. Stars are distant. Stars make their own energy. Stars are really, 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 really far away. The beam of light coming from a star through our air can get deflected by the air itself. And so it's called refraction, and it's our air, the different temperatures are actually bending the light a little differently, and the star's image seems to jiggle around a bit. We call that jiggling twinkling or scintillation. And so the beam of light from a planet, even though planets don't make their own light, they just reflect light from the sun. Planets are a lot closer. And planets are small disks in the sky. And so as we see them here. And so the beam of light from them is not going to get affected by our air quite as much. So rule of thumb, stars twinkle, planets don't. If the object is a steady object, very little or no twinkling, probably looking at a planet. If you're seeing a lot of twinkling, probably a star. Okay, so these planets will be visible for a while yet. Jupiter is going to be visible into 2022. So you can keep an eye on these. And if we go forward in time, you can see how the positions of these objects change slowly. Notice what just came into view. So I've got the date set for next week, the December 7th. Notice what came into view. Here we've got the moon right here. And if we go forward in time, you can see the moon moving across the sky at the same time. It's visible. That is the moon moving around the Earth. It's getting farther from new moon, moving farther away from the sun in the sky. So you'll see more and more of the lit part of the moon. And so you can see that by watching the movement across the screen on Stellarium. All right. So that's a fun tool. If you move around, we're starting to see to the east, just coming up in the east over the next few hours or so, we've got our wintertime constellations. If we go forward in time, then we've got the constellation Orion, the hunter right here. And there he is. And we've got these three stars right here, which form Orion's Belt. If you follow them upward, you come to the V that forms the face of Taurus the bull. And riding on the back of Taurus the bull are 6 or 7 or 8 or 10 or however many you can see with your eyes, stars that are part of the Pleiades or the Seven Sisters star cluster. A cluster is just a group. And so this is a group of stars. There's actually several hundred stars in that group, but the human eye can mostly see maybe up to 14 stars, more if you have a small telescope or binoculars. All right, I'm going to go forward in time a little bit more, a few more hours. And you can see that coming up later on, we have this thing right here. So if you follow Orion's Belt downward, you come to the brightest star in our nighttime sky. This is called Sirius, and it is called the dog star. So this is part of the constellation of Canis Major, the great dog. Canis Major and his little brother, Canis Minor right here, are Orion's hunting dogs. So those are fun to see. And Sirius will twinkle madly in the sky. It is very bright. So you will see that. Also notice that the colors of some of these dots are a little different. Betelgeuse is kind of an orange color. Rigel here is kind of a blue color. You can see star colors with your eyes as well. They're not going to be vibrant colors, but if you compare, say, Betelgeuse and Rigel. Compare those two stars. You will notice a distinct color difference between the two. So that'll give you a few things to start to look for. If you're brand new to constellations and observing the sky, the best advice I can give you, two pieces of advice to learn the sky is, number one, start with one or two constellations and go from there. Get comfortable finding those, then add on one or two more. So don't try to get yourself all overwhelmed with all 60 whatever of them that are visible in our nighttime sky over the year. Start with one or two. The other piece of advice I can give is that you got to keep practicing. You're not gonna learn this stuff all in one night. So just give yourself some time, get comfortable learning these. And the best way to test yourself as to whether or not you've actually learned it is to teach it to somebody else. So there we've got our early evening planets in the southwest sky. We've got the wintertime constellations coming up in the east. And then if we go to the morning hours, so I'm going to go to about 6 o'clock in the morning, we've got the planet Mars coming up in the early morning right before sunrise. So that will become more and more visible over the next many months. So that gives you a fun tool to go outside and actually find some stuff. I'm not going to spend a huge amount of time going over this because you can use this tool totally free. Just go online and give it a try. We love using Stellarium in our educational programs because it's just a great resource. And free is always a good thing. I also get asked a lot about phone apps. And the best advice I can give for a phone app is, number one, get a phone app you will actually use. Look for features that are something that you're interested in. And number two, the free phone apps may or may not work for you very well because a lot of times you have to pay to unlock certain features in the phone apps. And so you're going to end up paying anyway. So look for a phone app that has the features that you want, that you're interested in, that gets good reviews, and give that one a try. And don't worry about paying $2, $3, $5 or what have you. Usually that amount of money is worth it. Okay, something else you can see with your eyes. Eclipses. I hope you got a chance to see the lunar eclipse that happened on November 19th. But what an eclipse is basically an alignment of the sun, the moon, and the earth. Depending on which object is where, that determines the type of eclipse you're going to see. When it's an alignment between the sun, the moon, and the earth, so the moon is in between the earth and the sun, where the moon appears to pass over the sun and block part of it, eclipse part of it, that's called a solar eclipse. And so that's indicated here. Solar eclipses only happen at the phase called new moon. Then, if you've got a lineup of the sun, the earth, the moon, where the moon passes into the shadow cast by the earth into space, that's a lunar eclipse. So the moon is the thing being darkened in space, and that only occurs at full moon because you need the moon to be on the opposite side of the earth as the sun. Lunar eclipses are the best because literally no equipment at all needed. So again, this is not to scale by any means, but again, just to explain a lunar eclipse, sun shines on the earth casts a shadow into space. Normally, the moon's orbit misses the shadow. It's tilted with respect to the earth. And so normally it passes above the shadow or below the shadow. Well, occasionally, once or twice a year, it lines up with the shadow and it passes through the shadow. And that's what we call a lunar eclipse. Now there is a dark inner part to the shadow and a lighter outer part to the shadow. But it's when the moon is in that dark inner part, that's where people see the most color difference. So the most recent lunar eclipse, we saw a nice dark shadow of the earth on the moon as the moon was passing into and then out of the earth's shadow. And this is what it looks like when the moon is partly within the dark part of the shadow. You can see the curved earth's shadow right here. And this is overexposed, of course, to be able to get this dark part here. But as it moves into the shadow, you see that shadow appear to creep across the surface of the moon. It's actually the moon that's doing the moving into and then out of the shadow itself. And then when the moon gets fully within the shadow, we call that a total lunar eclipse. If it's only partly in the shadow, it's called a partial lunar eclipse. But if it does totally get within that dark shadow, that's a total lunar eclipse. You may have heard the phrase blood moon, and that term has only been around for a few decades, and it was first put forth by someone with apocalyptic tendencies, but the rest of the world has co-opted it because basically it's a good term to describe what the moon looks like. So it takes on this reddish tint. And that's due to the sunlight shining through the atmosphere of the Earth on the edge of the Earth at that point. And just like the sun gets redder when it gets really close to the horizon, the sunlight is shining through air, a lot more air, which scatters away the blue light, leaving you with the red and the orange light. Same thing happening here. The sunlight is shining through the air, the Earth's air at the edge of the Earth, and scattering away the blue light, leaving you with the more reddish or darkish red colored light. These colors, the color of the moon can appear orange, red, gray, a variety of colors. And that's determined by how clear the air is at that point, how cloudy it is, how dusty it is, if there have been a lot of volcanic eruptions, sandstorms, that sort of thing. So the color of a lunar eclipse can definitely change. We have 2 lunar eclipses coming up, May 15th in the early evening. I think it starts around 9 p.m. or so, May 15th, and then November 8th of next year. Both of those are total in our area. So put those on your calendar. The November 8th one starts at something like 2 o'clock in the morning. So if you happen to be up early for that, you might see it. But the May 15th one starts, or like I said, around 9:30 at night. So that should be a nice view as long as it's clear. Solar eclipses, you do need one piece of equipment to see a solar eclipse, and that is safe solar viewing glasses or some other means to see a projection of the image of the sun on the ground. So the sun, as you know, is really, really bright, not safe to look at. So when the moon appears to pass over the sun, well, we call that a solar eclipse. We do have one coming up on October 14th, 2023. It starts at 10:37 in the morning. This will be the maximum extent of how much of the sun will be covered by the moon for our general vicinity. So only about 40% in the Kenosha area, which is still pretty respectable, but you cannot go out and just point your eyes up at the sun and see this. You can't do that. The sun is too bright, it's too dangerous. So you need those proper solar viewing glasses or a pinhole projector or some other means to project an image of the sun on the ground. I've actually done this. You can make a little checkerboard pattern with your fingers, and the light shining through the holes in between your fingers can make essentially a pinhole projection, projecting several versions of the sun, images of the sun down onto the ground. It actually does work. So there are ways to do this that don't involve directly looking at the sun, but don't just look directly at the sun. You need the solar viewing glasses or project an image onto the ground using a pinhole projection of some way. Anyway, what's going on with this particular eclipse is, so if you're within this pathway right here during this eclipse, at some point during this eclipse, the moon is going to cover the sun, but this is a very special eclipse. This is called an annular eclipse. The moon will not completely cover the sun, even within that pathway in the US. The word annular comes from the Latin word annulus, which means ring, meaning there's a ring of sun left around the moon. Now, if you are near the edge of this pathway, the moon will be on the edge of the sun. So it'll sort of look like an eyeball kind of, where it'll be kind of shifted over toward the edge of the sun just a bit. If you are outside of this pathway, well, that's when it'll look more like this. The farther you are from that pathway, the less and less of the sun is covered by the moon, right? So this is an annular eclipse if you're within the pathway. If you're outside of the pathway, it's a partial solar eclipse. But people want to know when a total solar eclipse is going to happen. The frenzy in 2017, we get to do that all over again, April 8th, 2024. And during that eclipse, at some point within this pathway, if you're there, the moon will completely cover the sun. And then that will be safe to look at. I'll explain more in just a second. But we will all be outside this pathway for this one in the Chicago area. Apologies, I've got Kenosha covered up, but you know where you are. So we're a few hours away from this pathway right here. We're going to see about 94% of the sun covered by the moon in the Chicago area, and maybe more like 92% or 90% or something like that from the Kenosha area. So, so still pretty respectable. But if you are going to look at the sun, you need the proper solar viewing glasses or some solar projection in order to see that image. Now, from our area, it's going to look something like this. From inside that path of totality, it's going to look something like this. And at this point, if you decide to go see one of these eclipses, they're really great to see because when the moon 100% covers the sun, that's when you can take those solar viewing glasses off and look directly at this, because what you're seeing is the outer atmosphere of the sun. As long as the really, really bright part of the sun is covered by the moon, then this is safe to look at. It has to be covered 100%. And that will only happen for about 4 minutes during this next eclipse in April 8th, 2024. So the moon will completely cover the bright part of the sun. This outer atmosphere is only about as bright as the full moon. The full moon is safe to look at, so that would be safe to look at. But as soon as the moon moves away from the sun and it starts appearing again, you got to put those solar viewing glasses back on to be able to then look at the sun directly. So mark your calendars. That should be a lot of fun. All right, meteor showers. So the Kenosha area is kind of similar, I think, to the sky that I've got in the far western suburbs of the Chicago area. So we're a little farther away. We tend to see a few more dimmer things in the sky, including some of these meteors. So what a meteor is when a bit of space debris burns up in the Earth's atmosphere, traveling really fast, and due to friction, right, causing the object to burn up, causes a quick streak of light in the sky. And we call that quick streak of light a meteor. And if you have a lot of these things, it's called a meteor shower. Now, this is a picture that I took of a meteor last year. And I took 1,000 pictures this night. Over the course of about 2 hours, I got one meteor on camera. I saw about 10 of them, but I only was able to photograph one of them. So patience is a virtue here. But we do have some meteor showers coming up. Now, a meteor shower is caused when the Earth runs into the trail of debris left by a comet. And because we run into the same part of the comet's orbit every year, we can predict meteor showers. Random meteors in the sky, they happen a few times an hour every night. There's dim ones, there's bright ones. Meteor showers are so predictable because we run into the same trail of debris every year at the same time. And so the next major meteor shower coming up it peaks around the night of December 13th into the morning of December 14th, and it's called the Geminid meteor shower. If you trace the paths in the sky of all the meteors that you see, they will appear to radiate from the constellation Gemini. So hence the name Geminid. You can start looking for these Geminid meteors around 9 p.m. Go outside, face east, look up. No telescope, no binoculars. And the reason for that is with telescope and binoculars, you're looking at a smaller and smaller piece of sky. You're already limiting the amount of sky that you can see, which means you'll see fewer of them. You want the expanse of sky. You want 180 degrees or whatever it is you're able to see. You want to be able to turn your head and look around all over the place. A camera is only going to show you one part of the sky in one small direction. That's why I only got one photo out of 1,000 pictures. But with my eyes, I was able to see quite a few more. There's another meteor shower that peaks around the evening of January 2nd into the 3rd, sometimes the evening of January 3rd into the 4th. And that is called the Quadranted meteor shower. You go outside, you face northeast, and you look up. Best time of night is always going out after midnight. So a meteor shower is something, if you want to go out around 2 in the morning, that's usually a pretty good time to go. Then there's the Perseids. The Perseids get all the attention because it's warm out when they happen. So people want to look for that one. It's also during school break. So the night of August 11th into the morning of August 12th is usually a peak time to be able to go and see meteor showers. Again, go outside, face east, look up. That's all you need. And you do need to take light pollution into account. It always helps to get out under a darker sky. Go to the light pollution map, look for areas that are here, the yellows, the greens, the blues. And if it's clear out, that will allow you to see even more meteors. You've probably seen this and you just didn't know what it was. This is a picture that my husband took about 1.5 years ago. And you can see it's a time-lapse picture. It's not a meteor. It's taken over the course of about 15 seconds. And it's a very steady streak in the sky, which means this object was not blinking. This was the International Space Station in the sky. You've probably seen it, and you probably didn't know you were seeing it because it will look, if you just glance up, it'll just look like a landing airplane. But if you watch it for a while, you'll notice it's not blinking. There are no blinking lights on the space station. It doesn't need blinking lights. That's only for airplanes. And so where you can go to see the International Space Station is this site, spotthestation.nasa.gov. And I'm going to go to spotthestation.nasa.gov. So give me just a second. I'm going to switch my screen here, and I need to do a new share for my screen. There we go. All right, I think it's up on your end. So when you bring up the site, you want to then go to the map and let's search for Kenosha and see if it's in there. It is. And so we're going to hit Kenosha, and then it'll bring up a little flag here. If there wasn't Kenosha in the database, if you're somewhere and the town where you're at is not in it, just look for the closest little blue pennant on the map and click that. So you want to click it, and view sighting opportunities is what comes up. So let's click that. And the following International Space Station sightings are possible from Friday, November 19th through Saturday, December 4th. Sometimes you'll see a big list like this. Sometimes you'll see none. And it just depends on where the space station is and if it's light out here or not. So we see the space station just after sunset or just before sunrise. And so where it is in its orbit, where we are, where it's sunlight or not, that'll all change over time. So you want to consult the map. Or consult the list. So it looks like tonight, when we're recording this, there was a space station sighting a few minutes before we started. It looks like Tuesday, November 30th, we've got one that should be visible for about 5 minutes. And you want to start looking in the northwest, and it's going to end in the northeast. So this will tell you approximately where to look. So it's going to tell you about how high to look when it starts, and about how high up in the sky it is approximately when it's no longer visible. So it could be visible for less than a minute, like it was yesterday. It could be visible, look at this, last week it was visible for 7 minutes. It could be up to 10, depending on how high it is in the sky. So give this a try. It's really fun to go out and see the space station, because maybe there's an astronaut or a cosmonaut looking down at you at that particular moment, which is always fun. Okay, and then I'm going to switch sharing back to my slides. A second. All right. There's another site called Heavens Above. I won't go to that site, but here is the web address. It's also free. And if you go to this site and you want to go to 10-day predictions for satellites of special interest, click ISS, International Space Station. It will show you at that exact moment where the space station is over planet Earth, which is kind of fun. And then it will bring up a list of the sightings. Now, this will give you even more information. If you click on one of the dates, so if you clicked on one of those dates, it will show you a star map, and it'll show you where to look and what time to look. So in this star map, in the middle is straight overhead. The circle shows you the horizon. So this, it looks like it started to be visible about a third of the way up in the sky, and then it went toward the horizon to the northeast. So I like Heavens Above. Again, it's free, and it'll give you a star map, but some even more information to be able to look at that. But one other thing I want to point out, over here on the upper right-hand part of the main Heavens Above screen, you want to go into the database and put in your location. So you can create an account if you want, but you can also just search in their database, work through it, and get your location. Otherwise, it's going to start with some random, it's just going to start with some other location, probably over in Africa. So near 0 degrees latitude and longitude. It just starts there for everybody. So put in your location, and then you can get your actual timings for the space station based on where you are. So make sure you do that before you go to the timings. Otherwise, it's going to give you the timings for 0 degrees latitude and 0 degrees longitude. All right. Now, something that our friends up to the north in Wisconsin and Michigan get to see a little more often than we do here in Illinois is the Northern Lights, the Aurora. Not quite as much in Kenosha. It helps to go out where it's dark and go up north. If you've been vacationing in northern Wisconsin, again, Door County, that sort of thing, or even farther north, Upper Peninsula, you'll see the auroras definitely more often up there. Now, notice this picture. You probably won't ever see this variety of colors. Just like I mentioned before, your eyes are most sensitive to certain colors. One thing I didn't mention is your eyes are not that sensitive to color in the dark. So when you look at an aurora, you're probably going to see some that have a greenish tinge. You might see a reddish tinge, but you're probably not going to see these purples and pinks and blues and indigos and that sort of thing. But that's caused by material from the sun interacting with the Earth's magnetic field. And then that interaction eventually causes the Earth's upper atmosphere to glow different colors, depending on the energy level, the air, the composition of the air, oxygen, nitrogen, that sort of thing. So the colors can be different from one aurora to the next. One thing you will see is structure. You can kind of see it in this image here. You can see that it looks like curtains. Those curtains will move, they'll shimmer across the sky, they'll swirl, do all sorts of crazy dancing and everything that you will see. So don't expect to see vibrant colors, not often, but do expect to see movement and structure and all of that. It's really amazing if you've never actually seen one. I've seen two, and they're worth it. They really are. as long as you know what to expect. So there is a site, and I'll have this on my final screen. There's a site you can go to get a prediction for where the aurora will be visible. And on this site, if you're underneath where the green band is on the site, you have a chance of seeing one. If you're within the area bounded by the green line, then the closer you are to the green line, this green line, the lower the aurora will be in the sky if it's visible at all. So they're hard to predict. We can't predict more than a few days in advance if they're going to be visible at all. Sometimes they are, sometimes they aren't. But that prediction can change. There's also this site right here, spaceweather.com, and it just gives you another version of that prediction. This is from the from NOAA, and so it's another good resource to have. So here is the screen with all the resources. So I've got Stellarium, got Heavens Above, Spot the Station, great sites. The Aurora Forecast, spaceweather.com. I'll go to AMS Meteors. I didn't show you that one yet. Darksky.org is for the International Dark Sky Association, the light pollution map information. Earthsky.org is a great site to go to with some tips of simple stuff to look for in the sky every night. If you want to just look for one or two things in the sky, a bright star and a planet or something, they'll give you something to look for every night. Time and date is a great resource to go to, especially the sun and moon eclipses section. So you can see when is the next eclipse visible for my location. And then of course, can't do a talk for a library without mentioning a resource the library probably has access to, Sky and Telescope magazine, or more than likely, because they are based, I'm pretty sure, in Waukesha, astronomy magazine. So that one is Wisconsin's own astronomy magazine. So definitely check either of those out. There's usually a centerfold of both of those sites, or both of those magazines, that has a monthly sky chart. And so you can look for some interesting stuff to see in the sky each month. So let me go real quick to, I'm going to stop sharing and then switch real quick. I want to show you, a couple of these pages that I didn't show you before. So I'm going to go back to the web. There we go. Okay, so this is the Aurora Prediction. So if we were in northern Wisconsin tonight, it looks as though if the prediction is right, then northern Wisconsin might start to see the aurora on the northern horizon. So, and it looks like northern Minnesota, northern North Dakota might see the aurora slightly higher in the sky. If this green bar were down over Wisconsin or over northern Illinois, we would have a chance to see the aurora overhead, all right? Okay, then, and I'm gonna stop sharing and then go back to amsmeteors.org. amsmeteors.org is the website for the American Meteor Society. It's a group, I believe they're all amateurs, if I'm not mistaken. But if you want to go to the meteors section and go to the meteor shower calendar 2021-2022, it will tell you what the active meteor showers are right now. It'll tell you the phase of the moon, which is always good to know. If it's near full moon, not a good night to go out and see dim meteors in the sky. But coming up, we've got the Geminids coming up. If you're watching this before December 13th, the Perseids happen as well. The peak night over here, December 21st, 22nd. So that's the night of the 21st into the morning of the 22nd. And that is really close to full moon. So not a good night to go out and see the Perseids. The Quadranted's coming up on January 3rd. It looks like the peak is the night of the 2nd into the morning of the 3rd. And this is new moon. So perfect for going out and seeing meteors. But they also give a nice little description for each one, what to expect to see. And then finally, the this number right here is ZHR, zenithal hourly rate. if the point that the meteors were appearing to radiate from was directly overhead in your location, you would expect to see 120 meteors an hour under a completely dark sky. The problem is, most of us, that radiant point will not be directly overhead when the meteor shower is happening. So you always have to knock this number back by quite a bit. So even though this says 120 meteors an hour, that's under a 100% dark sky, assuming that where they're radiating from is overhead. It's probably going to be down near the horizon. So you're going to see, you're already knocking back your number of meteors that you're going to see by at least half. If you're under a light polluted sky, knock it back by at least another half, if not more. So always temper the numbers with a dose of reality. Be happy if you can see 5 to 10, and then anything past that is gravy.